put this short video together to help explain some of the ways that we can use accuracy control for a number of things, for putting the modules 865, 866 together. And sometimes you just need some visuals to be able to do this. So Mark, basically I'm going to be using you as a sounding board here. But if you take a look at this and you'll say, hey, I recognize this. This looks like the module either 865, 866. And we can see we have our whole outline here. We have the deck. We have some deep girders. And we also have a watertight door that the launch handler recovery system has to go through. And from what I understand, Mark, let's go ahead and put on the let's see now. Let's go ahead and put the roller bearing foundations in, and we can take a look right now to see how those roller bearing foundations then got some nice beautiful features here that are now attached to the deck, and we do have a height, and these are the foundation, or I guess green blocks that simulate the foundations that the roller block are going to be bolted to. And I feel these are going to be very critical features that we're going to want to use then for when we start picking our datum reference system. And I'd like to go right into that and talking about a datum reference system. For instance, if we were to go ahead and install these foundations, you always have to understand what are you measuring from. And what I've seen in the past is they say, well, we'll just measure from the deck down, and then that'll give us the height of those roller bearing foundations, so you get a little better view here. So we just measure down from the deck, boom, and say, okay, that's where our roller bearing foundation is going to be. But what happens is that we found out on LCS 3 that this deck had, I believe, up to 6 inches of variation from the lowest to the highest point. Not a real good thing to measure from when you're looking at installing something that probably only allows you a shim of maybe 3/4 of an inch, maybe 1 inch. So you're talking about 25 millimeter shim that we're allowed to put in there. I know when we put it in LCS 3, we set up piano wires, and we took an average. We actually did a survey of the deck to see what a best fit plane would be in that deck, and then established a water line from there. Hello, this is Joe. Okay, let's go ahead and talk about the features that we're going to use to set up our datum reference system. And one of the most important I want to say the primary datum that we want to set up to is a water line. And there's a lot of different ways. Somebody might say, no, you want center line of ship. Somebody might say a frame line. Based on my experience with putting launch handling recovery system, other people might have a different idea, but for now I think the water line is the most important datum reference, or the primary datum that we can use. And the features that we use to get those or to establish this primary datum, and if it'll let me do it here, we want to use the bottom of the roller bearing foundations, and we also want to have them qualified. So what we really want to do is make sure that if we do a survey either with a laser tracker or a theodolite or a scope, it can even be a laser beacon, to make sure that all these features, these would be the flat surfaces of the foundations, have to fit within a tolerance zone of say 7-8 millimeters or a 1/4 inch. And so before you even get started, if those foundations don't fit within that tolerance zone, probably want to stop and rework the foundations. But for what we're going to do right now, we're going to assume that those foundations were put in and they're all going to fit within a tolerance zone of say 7-8 millimeters. So if you had to run two parallel planes using two laser beacons, or you want to just use your theodolite, you go through and make sure that from the highest to the lowest reading that they're all going to fit within that tolerance zone. Okay. From there, what we'll do is we'll establish this water line based on a best fit plane through that tolerance zone. So now you got this beautiful features here. You got something very accurate. Now you can set up a water line that all of a sudden now you got something else. Now you can set up your tertiary and your secondary datums. Also then that you'll be able to have a reference that you can measure from. You go back up and set up your scopes and so forth. I don't care who comes in to do this. You bring a guy in with a laser tracker, or you bring a guy in with a total station. The first thing they're going to say, well, what do you want me to set up to? Well, this is what we have to tell them. This is what we want you to set up to. So now we have this waterline primary datum, runs across the ship. I think this is running, I forget how many millimeters above baseline. The baseline's down here at 0. I think it was calculated off the deck, something like 500 millimeter from the deck. So if that's a 10-1 meters from base, the 0 point, and you're coming down 500 millimeters, like 496 is where you want that to be. That's where your water line's going to be. Now your next or secondary datum is going to be a center line. And so anyway, if we go ahead and set up that center line datum, you say, what features would we use then to set that up? And so, well, you know, and we had the same problem in LCS3. We know that the crane has to fit through the watertight doors. And from what I remember, there's only, maybe 8 millimeter clearance. There's not much on either side. Not a lot to play around with there. So what I would do is I say, because it has to fit through these doors, that's a real good feature to pick to say that's what I want to set up my secondary datum. Now that's on one side. Now on the other side, well, what do I got on the other side? I got this big open hole here. What am I gonna set up on that? Now, there's a couple things, and I'm not quite sure how you'd want to do that. But I know this stuff right out here, that varies a lot. It's kind of flimsy, it's thin, it's not real good. But one of the things I'd probably say to do then is, because we have these holes maybe already in the foundations, I may take a distance from the center of the hole pattern there to the center of the hole pattern on that last roller bearing foundation. And basically then I'd have a distance from here to here on the roller bearing foundation. Boom, boom. And I want to take the halfway point, and I want to take a distance from here to here on the door, halfway point. And that's where I'm going to want to locate that secondary datum, but that secondary datum is then going to be perpendicular to your first primary datum. So basically this center line secondary datum is then going to be located based on your last roller bearing foundation, distance between the hole patterns, and then also between the center line of the door. So now you got two really important I want to say datums that we can set up for, or set simulated datums with the scopes and lasers and so forth. And this is really the hardest part of getting set up to do this. My tertiary datum is going to be a little bit more flexible, and basically you're going to pick a frame somewhere, and that thing's going to be perpendicular to your secondary and your primary datums. But right now we're going to focus just on those two datums for setting things up. Because now, once we have these two datums, we can start measuring where our hull structure is. To say, we know from the CAD model that we can put targets in all our deep frames. We can put targets on all the edge of our hull. And then we can come out based on this new datum reference frame of this primary waterline and then this secondary center line of ship. Let's go ahead and say for this tolerance zone, let's go ahead and, I do that all the time. Let's go ahead and put the tolerance zone in. I think I did this. There we go. Let's try it now. And this new tolerance zone, you can see, is going to be in light blue or cyan. And what we want to do is we want that hull structure to see if it's going to fit within that tolerance zone. And say that you make that a quarter inch or half inch tolerance zone. What I would then do, based on setting up my total station on this primary and secondary datum, I'd set targets up, boom, 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 all the way around the hull. And I'd go and check and say, you know, how well does that hull fit within this tolerance zone? And what are the points that are out of the tolerance zone? We also then could set targets on the deep frames as well. You know, how high, how low they are. The same thing with the deck. Come along, do that. So before you go to join these modules up, you actually can know, yeah, it's going to fit or not, because you're going to do it to both sets, 865, 866. So anyway, that I'm not sure this is something new or novel to you, but to me it just made a whole lot of sense that that you do set up a datum reference system based on the foundations that you have already installed. And again, you're going to have to qualify those foundations and make sure that they're in properly. So anyway, let me know what you think, and give me a call back. I'd love to hear your thoughts.